All right, we just practiced finding the area under a curve or between two curves, and now we're going to do volumes of solids of revolution. Well, what does revolution mean? Revolution means to spin, to revolve, to rotate. A solid of a revolution is formed when a flat two-dimensional shape is rotated around an axis. Consider the flat region below to the left. When this region is rotated about the x-axis, the solid pictured below on the right is formed. The objective of this lesson is to learn to find the volume of such a solid. Now, imagine slicing this solid into individual discs. A disc is like a frisbee, okay, or a plate of height of 1 unit. So one slice, if you just slice this, you would get a single, like a circle, okay? The volume of one of those discs would be pi r squared times h, because it's a mini cylinder, okay? So we have our little slice, and we take this slice and we rotate it, and if this is the axis of rotation, then this would be the radius of the disc. And this little piece is our height. So if I were to turn this disc, well, let me draw it vertically. So here is our disc, but you can't really see it, right? Here's the center, this would be the radius, and this would be the height. If you were to turn that on its side, it makes something like this, okay? So this is the height of our disc and the radius. So this is a bunch of slices. If h was 1, then that's what it would look like. Now, we're just talking about one slice, but if you integrate from a to b, then you have the sum of all the discs. So the sum of all the discs is from a to b, and it's going to be pi r squared. R, this is your radius here. What's r? R is going to be the distance from your function, this curve, to your axis of rotation. Okay? You can even, we're going to write the pi in front because we don't want it to get in the way. But this piece here is our radius. Okay? Notice that the axis of rotation is the x-axis and the bottom function of the region is also the x-axis. Imagine for a moment what the solid would look like if the axis of rotation were still the x-axis, but the bottom function of the region was a line, C. The solid would look similar except for the fact that there would be a cylinder that is cut out from the center. So what are we talking about here? We're talking about taking this area. So it always starts with an area, a two-dimensional area. And we're going to rotate it, but we're not rotating it around here. There's going to be a gap. We're going to rotate it around this axis. Okay? So the way we do that is we pretend there's no gap. To find the volume of this solid, we would find the volume of the whole solid that we found previously. And then we would subtract out the solid in the middle because we don't want this piece. In order to do this, we will use the formula below to find the volume of such a solid. The outer function is defined to be the function that is farther from the axis of rotation, whereas the inner function is defined to be the function that is closer to the axis of rotation. So we have a pi r squared minus a pi r squared, but it just comes out to be pi and then r. We're going to call this big R, and then we're going to call this one little r. It's a little confusing until we get to some examples. So let's turn the page and do some examples. Okay, here's some examples. Ready? If the axis of rotation is the x-axis or parallel to the x-axis, the integrand needs to be in terms of x, and the limits of integration need to be the x values of the points of intersection of the curves that form the region being rotated. Consider this region pictured to the right that is bounded by these two graphs. These are the most simple equations, right? We have a parabola and a line. Find the volume of the solid formed when the region is rotated about the x-axis. So what we're going to do is, let's write the volume formula. So the volume formula used to go from A to B, and it's going to be the outer minus the axis of rotation squared minus the inner function minus the axis of rotation squared. Okay, so volume of this one, we're going from the x values. That's what you're going to use, -1 to 2. Now what is the outer function if we're going about the x-axis of rotation? This is what we're going around. So which one is further away from the axis of rotation, the line or the parabola? It's the line, right? So the line is x plus 2. Now, tell me what the number of our axis of rotation is. What is this value? It's 0, right? So this is going to be -0 squared minus the inner function, is the parabola that's closest to the axis of rotation. So the inner function is x squared, and our axis of rotation is 0. I gotta clear my throat. Okay, we're gonna find this answer using the calculator. You can see I was so mean last year, and we did it by hand. But for the video, we're gonna use the calculator. Ready? Let's add a calculator. Control, integral, -1. Oops, -1 to 2. X plus 2 in parentheses, and then we need to square that. And then we're going to subtract. Okay, it's x squared. What in the world is going on? Oh. Okay, I need more parentheses, I guess. X plus 2 squared. There we go. Minus, what is x squared squared? It's just x to the 4th, right? Okay, guess what? We forgot something, and this is what happens to students all the time. Let's check our actual formula. We're missing something in the formula. Something so important. Ready? What are we missing? What needs to be in front? Pi. So go back to my formula and let's put pi, and go back to the calculator and put pi, and I'm going to put it all the way in front. Where do you find pi? On the gray button, it's right here. I think on the black, you have to find it somewhere else. So that is our volume. The volume should be bigger than the area because there's more volume. Okay. All right, let's do another one. So now we're going to find the volume when the region is rotated about the line y equals 4. Okay, let's draw this line. So do you see this line? Y equals 4. Okay. We're still, the starting and ending points are still the same, correct? So we're still going from -1 to 2. But this time, what is our the outer function? So you have to say what is furthest from this axis, okay? So furthest from this axis is now the parabola. Sorry about the announcements. Minus the axis of rotation. So we're saying x squared minus, where is our axis of rotation now? It's at 4 squared minus, now what's the inner one? So you see here the curve is the outer, and the inner one is the line. What is that? X plus 2 is the inner function because it's closest to the axis of rotation. So x plus 2 is our line minus the axis of rotation dx. Did I remember my pi this time? Yes. Let's clean this up before I plug it in the calculator to find the volume. X squared minus 4 squared minus, what's x plus 2 minus 4? That's going to be x minus 2. squared dx. All right, to the calculator. Here we go. Look at me cheating. I did copy and paste. Let's do x squared minus 4, okay, minus parentheses x, I don't need that 4 anymore, so x, let's see here, x minus 2 squared. Good. So you see the same shape is rotated around different axes. It's going to give different volumes. Find the volume when the region is rotated around the line y equals -2. Ready? Draw the line. What happens when we're going to subtract the -2? It's going to become positive. Okay, what's our outer function? So what's furthest? The outer function is now the line, and the inner function is the parabola. So volume equals pi, -1 to 2, the outer function minus our axis of rotation. What's our axis of rotation this time? -2, and that is all squared, minus the inner function, x squared, minus the axis of rotation. Okay, what happens with these double negatives, minus minus? They're going to turn to positives. Okay, we have 2 plus 2, which is 4. And then x squared plus 2 squared dx. Okay, let's see what this volume is. Now I'm on the calculator. And I have an x plus 4 squared minus an x squared plus 2. Oh, they keep getting bigger and bigger. 101.788. Next page. So this is where it gets much different. Ready? If the axis of rotation is the y-axis, or parallel to the y-axis, then the integrand needs to be in terms of y. And we have not done that yet, you guys. And the limits of integration need to be y values. Are you ready? Here we go. Do you see how this says y equals plus or minus x, square root of x? We need to solve for x. How do you solve this for x? We want it to say x equals, well, what's the inverse of a square root? Square both sides? So x equals y squared. That should make sense. Do you see how this is a parabola coming up from the y-axis? So it's y squared, just like x squared would look like this. Okay? And now solve this one for x. This is going to say x equals y plus 2. Do you see that? So find the volume when the region is rotated about the y-axis. So now we're going, okay, what do the limits have to be? The limits have to be y values. So the lower y value is -1, and the upper y value is now 2. And if we're going around the y-axis here, which one's the outer function, which one's furthest away, and which one's the inner function? So the outer function is going to be the line, and we're subtracting 0. And then the inner function minus 0. And then we have dy here. Okay, so that's how we're going to do these. And I'm kind of out of time. So why don't I take a, I don't know, I'm going to figure this out. Read Google Classroom for more.